Okay, so in the last session we have completed our in the CCNA. What
Sir,
OSI layer? Yeah,
sir, you're
tell me.
sharing screen?
Oh, sorry. Okay, in the last session we have completed these fundamentals, right? About media and everything we have completed, and all this uploaded into the YouTube. You guys can visit to our channel and you can start from the beginning. Okay, so these are the fundamentals. So we have completed in last session subnetting and FLSM and VLSM, right? So today we'll go with the supernetting and the summarization. Okay, so what is the supernetting and this is also kind of form of subnetting only. So this is the last day of this numbering system and calculation. From tomorrow onwards we'll start doing the practice. Okay, practicals. So have a patience, and we're just going to start supernetting. Okay, so what is the supernetting and how it works actually and why it is required? Someone is asked me last in the last session. Someone is asked me, when we are having more than 254 IPs required, what will have to do, right? So the answer will be like this. Let's suppose one of the company has started with the 200, 200 PCs, means 200 users, with the IP address 192.168.10.0/24, means class C IP. After 1 years, the company has been growing up, and the requirement is we have to be we have to be installed 100 PC more. So total PC requirement is total PCs available is 300 pieces, right? So, but the IPs with the slash 24, how much IP we are having? 254 valid IP we are having, right? But the requirement is 300. So what are the option we have that we can also allow these 100 pieces with the same, without changing anything? We just wanted to allow them into that. We wanted to, you know, install this PC with the same IP series without changing the IP, because we know it's like if the different class A, B, C cannot communicate each other, right? So, and also we knows that when in the class C we are having with the slash 24, we are having 25 254 valid IPs only. So in this only 255 four machines we can connect, but we are having 300 pieces, right? So in that case, we cannot go to change that IP, because if you change the IP series, might be there is a firewall, there is a router, right? So many policies are available there. So if you changing the IP, and if you changing the IP, the many policies we need to change at the same time, right? So it will be hectic. So without changing any policy, without changing the IP series, how you guys are going to be establish the communication within this thing, right? So this is the main concept of the supernetting. Supernetting is a very good concept. Okay, it will use in your real time. Let's suppose. So what is the solution now for this? Any question on this,
No, sir, clear.
Hussein?
Yeah, clear.
So let's
No, sir.
suppose company name is whatever that XYZ company name. 200 pieces they are having with the IP address by default IP. This was the by default IP, right? 192.168.0.0 is our by default IP, and just keep one more IP with the same series 192.168.1.0 series for this 100 pieces, right? 192.168.1.0. So just convert this both the IP into the binary here. Okay. So 192.168, then remaining will be a 0.0.0 for this one. Okay, 0.0.0 for this one, and second IP 192.168 0.0.0.0 till 1, right? Because in the third octet we are having a 1 only. So 7 bit will be the 0, because our magic table is telling 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, and 2 to the power 1, and 2 to the power 0. So in the last seven bit 1, 2, 3, 4, 5, 6, 7. What is this? This is completely 0, means off bit. Last octet is only on. So last octet value is just a 1, right? So till just converted the binary here. Whatever the matching, just let it be match from here. Okay, because here continuously 70, here continuously 70, right? So here you need to convert this into that, what, into into that into that on bit like 1. Okay, so whatever this matching, it should be a 1. Okay, So 1, 2, 3, 4, 5, 6, 7. Already how many bits we are having? 8 plus 8, 16. 8 plus 8, 16 bit plus 7 bit. So total 23 bits. So our new CIDR will be slash 23, right? Correct?
Yes, sir.
192.168.0.0 slash new CIDR will be slash 23. Okay, our network ID will be 192.168.0.0. Our broadcast ID will be 192.168.1.255. Okay, so our again, if you are adding, you'll get multiple, but just leave it this. Okay, so how many networks? 192.168.0.0 is our base network in the by default network ID, but the broadcast ID will be the 1.255 because last will be 255. Okay, so how many after like total 32 bits we are having? So minus 23. How many bits are remaining? So total 9 bits are remaining for the host. Okay,
Yes.
remaining for the host. So 2 to the power 9 equal to 512. 2 to the power 9 equal to 512 minus 2. So the
Right, sir.
valid IP will be 5110. Okay, so
Yes.
510 PC we can use without changing the IPs. Got it my point?
Yes, sir. Yes, sir.
So this is the way if you in, if you are stuck in kind of this kind of situation. So remember there is a supernetting option. From there you need to use same range, same class IP, convert into the binary. Whatever the bits are matching, just keep all as a network bits. Remaining will be a host bit. Okay, got it my point? So now in this
Yes.
situation we are our requirement is 300, but now we received 510 pieces we can connect without changing the IPs. Okay,
Yes, sir.
so this is called supernetting. Clear? That I will show you in the practical when we'll do the practical. Okay, so I'm stopping the recording because we'll create small videos.